Welcome back, everyone. So today in this video we're going to quickly just talk about electric power, right? So how much power does a circuit dissipate? How much power does an individual resistor dissipate, right? You just use the values that are for a whole circuit if you're looking for the whole circuit, or just that one resistor if you're looking for that one resistor. Right? So this is how we're going to look. Right? The electric power equals the total current in the circuit times the electric potential, the voltage. Right? Now, I can actually take Ohm's law and make other equations out of that. Right? So remember what Ohm's law is. That says that V equals IR. Right? So let's say a question wants to know the power, but they only give me current and resistance. Well, by knowing that, I can take my V equals IR, I can take this IR, plug it in right here for the V. Then I'll have I times R, which leads me to I squared times R. Okay, so I have power equals current times voltage, or current squared times resistance. What I can also do is, let's say I rearrange my Ohm's law and plug it in for current. That's V over R. Right, so I can take this, V over R, for my current, plug it in right here. Then I'll have V times V, all divided by R, which will give me V squared over R. Okay, V squared over R. So here are our equations for electric power. Right, pretty simple. Just plug in the values and get going. Right, if you're looking for the power for the whole circuit, just make sure you use the total current and the total voltage, or the total current and the total resistance. Right? If it's series or parallel, just calculate what you got to calculate. If you're just looking for a one resistor, right, just make sure you use the stuff for that one resistor. Right? No big deal. Nothing too crazy here. All right? The units for electric power are still watts. Right? I can kind of show that. So the units for current are amps. The unit for voltage is volts. But each of those can be split up into other things. An amp is a coulomb per second, where a volt is a joule per coulomb. Okay, so amps times volts equals coulomb per seconds times joules per coulomb. Well, my coulombs cancel out, and I'm left with a joule per second, which, if you remember from mechanical power, is a watt. So it's still watts. Nothing new or groundbreaking there. All right. Now, sometimes, right, instead of looking at the total power that a circuit dissipates, they could be asking you to find how much work or how much energy was transferred during that time. All right. So we know that power equals work over time. Right? So I can rearrange that to say work equals power times time. All right, so I'm going to use that to help me find electric work or electric energy use. Okay, so that's W equals power times time. Well, let's see. We know that electric power is current times voltage, so we'll plug that in. Right, so work equals power times time. Power is current times voltage, still times time. But we also know that power can be I squared times R. So plug I squared R in for our P, our power. Or, right, we can say that power is also V squared over R, all times T. Right, again, plug in your V squared over R for your power. Right, and this is a set of equations that we can use to find the electric energy, or electric power. Right, now, something I want to make clear is sometimes the question will ask, what is the rate of energy use? Okay? When you hear what is the rate of energy use, that's asking for power, right? Because power is that rate of energy transfer, or rate of work being done. If they ask for what is the electric energy, then you look for your work or your energy, right? So it's important that you kind of put those two things separated in your brain, right? Rate of energy is power. Energy is energy. All right, so that's pretty much it. It's not too groundbreaking. It's not too earth-shattering. I think you'll have this pretty good. So until next time, I'll see you later.